Good morning. Welcome to our first and only session of TEAS here in Singapore. Before I get started, I'd like to make a request to presenters. Please try really hard to get us your slides at least the night before the session. Getting things to us an hour, 5 minutes before mean you're going to get your old version. Because sometimes, like right now, we weren't able to download for some reason. I don't know what was going on, but it meant that we were not able to download the latest. So if you don't get us before, well, you're going to be stuck with whatever you've given us. So please send at least the night before. With that, we'll get into the real session. So as usual, our material is uploaded and available on Data Tracker. Up here, you can see our note well. Second day into the week, we should be familiar with it. Basically, anything you say here becomes part of our permanent record. If you're not familiar with the note well, please go to the IETF site and take a look. You can't hear me? What? Can you hear me? Oh, okay. Sorry about that. So that's a fitting time to point out that you couldn't hear me because please do talk at the microphone. We are recording both video and audio, so that's really important. Also for remote people, it's quite helpful. Please also say your name for the minutes. We are using Etherpad. As usual, you can find it off the tools page. This is the shortened version. If you go to toolsietf.org, working group TEAS minutes, as shown on the screen, you can help contribute to the minutes. Even if you're not going to write anything, please go there and make sure comments that you make or comments that you hear are correct, and feel free to edit that. And this applies both for people that are in the room as well as listening remotely. And you'll see that we do have a few. We note that Matt is not here, but he was very helpful in preparing for the session. And as usual, he is very helpful in preparing minutes. We have a couple of recent RFCs. It's always nice to see progress from the working group. We have one document going through in the editor's queue and a few documents that are going through the publication process. We're going to get updates on, I think, 2 or 3 of those early on in the session. We have a couple or 3 documents that are working through the process after last call. These are getting pretty close. We have a couple of actions or open items that we'll discuss today. We have a few documents that are preparing for last call. We're moving these forward as a set. Actually, I did have, well, I have a question on one of these. We'll come to that in a moment. We have 2 new working group documents, and we have several working group documents that we expect to adopt based on how things have progressed. 2 of those we have not done an IPR poll on, but we expect to do so shortly. We have no liaisons or incoming communications. I think at this point we're all very familiar with our IPR process. Please do respond to our calls for IPR disclosure in a timely fashion if you're an author or a contributor on a document. Not doing so slows us down. It's really important to have conversations on the working group. This is mailing list. This is particularly notable for those who are authors of working group documents. If you are an author of a working group document and you want to make a change and you talk among yourselves and get agreement and publish that change, that's okay, but that doesn't constitute working group consensus. What constitutes working group consensus is getting buy-in. So if you work on in private and then publish a change, you then have to have a discussion with the working group why you made that change and be open to reverting that change. On the other hand, if you have the discussion on the working group mail list, even between the authors, anyone in the group has an opportunity to contribute, to chime in, and at the end of a discussion on list, if agreement is reached, that is consensus. So it's really important to use the list even among just authors' discussion of working group documents. I think that's it for the update. I was going to ask a question, but I'll ask it on the list. So we failed to update the latest ones. I don't know what the network problem is, so we'll stick with the ones that we had downloaded. I downloaded about 9 o'clock this morning. So hopefully that'll be close enough for whoever sent in updates.
Can you guys hear me okay? Next on the agenda is the working group document status. We have 20. How about now? Can you guys hear me okay? Okay. We have 20 active working group documents. There are 6 in the post-publication requested process. There are 3 for which we just finished last call. There are 3 for which we are about to commence last call. We have 2 brand new working group documents. The 00 versions of those got published yesterday. So of the remaining 6, 3 are on the agenda today. So I'll go over the status of the remaining 3 in this slide deck. First up is the associated co-routed bidirectional FRR draft. A revision for this was published yesterday. The changes were included alignment with RFC 8271. That's the GMPLS FRR document, and an addition of a section that talks about one-to-one backups. This was published yesterday, so please do give this a read and reach out to the authors on the list if you have any questions or concerns. Next is the PCECC use cases document. We did not receive an update for this. There were no changes to the draft since the last IETF meeting. There was, in the status update that was sent prior to the last meeting, the authors did indicate that they wanted to add an additional use case. I don't know if that's still part of the plans. If there's somebody from the author's side, either here in this room or remote, it would be useful if they can chime in now and give an update. I don't see anyone approaching the mic. We will try and reach out to the authors offline and see if they can send a status out. Next is the TE metric recording draft. This expired a while ago. We even stopped discussing this on the list. The authors suddenly woke up last night and published a new rev. There's still some outstanding comments from mid last year that need to get addressed. So in terms of next steps, the authors would need to discuss this on the list and stay awake for the rest of the process. That's all I have in this deck. Can you guys hear me okay? Folks at the back? How about now? So for some reason, this turned out to be really messy. This is an update on the network assigned upstream label draft. I'm one of the co-authors. During the AD evaluation, Deborah found a few issues with this. We submitted a revision late last month addressing those concerns. This slide goes over the changes that we made. The document now updates RFCs 3471 and 6205. This is in addition to updating RFC 3473. We added some text in the introduction section talking about the reasoning behind these updates. There was some text in the backwards compatibility section that wasn't crisp enough, so we edited that, made sure that there's no ambiguity with respect to the backwards compatibility procedures. We also added an INR request to include a new subregistry for the for special purpose generalized label values. The all ones pattern that's used in this draft for upstream label is the only one in this registry for now. We also added some text to clarify the scope of the procedures. The scope of the procedures is limited to the exchange and processing of the messages between a given upstream node and its downstream node. With these set of changes, we believe that all the concerns raised so far have been addressed. So at this point, we're looking for some guidance from the chair and the AD to, with respect to the next step for this draft.
So there were no technical changes or substantive technical changes, correct?
The addition, except for the addition of the INR section. There were no technical changes, yes.
Okay. So generally, we don't do a additional last call unless there's substantive technical changes post last call. So I think that we can just move forward with this version. Of course, unless our AD feels otherwise, but that's been our practice. If there's, she's nodding her head no. I don't know if she wants to come to the mic. If anyone has any other comment, now would be a good time. Otherwise, we'll move forward with the document. Thank you.
This is an update on the RSVP scaling techniques draft. There were some comments and questions raised on the mailing list during the IESG review. We addressed all of those. This slide and the next will give you an overview of the changes that we made and highlight the discussions that we had on the list. The first thing we changed was the title. It's now titled Techniques for Improving Scalability of RSVP Deployments. We added a statement in the introduction saying that the support of capability object is a prerequisite for the two techniques discussed in the draft. We have an appendix in the draft. We were asked to add a reference from the main text to the appendix. We did that. We were asked to add an abbreviation for periodic retransmission interval for unacknowledged path and receive messages. We did that. We were also provided some good text suggestions by Elvin Davis to improve the overall readability of the draft. We accepted that and acknowledged his contribution. There was some debate on whether this updates RFC 2961 or not. After a fair bit of discussion, we all agreed that that wasn't necessary. There's some text in the draft that talks about retransmission of unacked path and receive messages after the rapid retry limit is reached. There were some questions on whether this violates any of the RFC 2961 procedures. We clarified that on the list and said that that isn't the case. There's a question on whether these techniques are enabled by default. The answer is yes. That's what is recommended in the draft. There's a question on what happens when a refresh reduction capability is deactivated. RR is a prerequisite for the two techniques. So deactivation of refresh reduction would result in deactivation of RI, RSVP, and per peer flow control. All of that is documented in the draft. At this point, we believe that there are any open issues. We believe that all the questions and comments that have been raised so far have been addressed. So the next step would be to get the ISG reviewers approve this and get this document progress to the next stage. Any questions?
Yeah, sorry about driving this from PDF versus the original PowerPoint. You see there's some conversion problems. For some reason, the PowerPoint links disappeared from Data Tracker, so it's a little hard for us to just consolidate them. Well, hopefully it'll be fixed by the next meeting.
Good morning. My name is Dieter Beller. I'm one of the co-editors of the LSP diversity draft. This is a very brief status update of what has been what happened with the draft and what the next steps are. Current status: the LSP diversity draft did undergo the IESG Directorate review. The outcome was that it's approved. And that revised IDs needed. We actually received quite a number of review comments from the reviewers, and we were able to address all the comments, but two are still missing. The comments from the Obster review and the Security Directorate review comments are outstanding. We published an update of the LSP diversity draft yesterday. So far, all the changes that have been made to the draft were only editorial, and the next steps are to actually address the outstanding comments from the two reviewers and submit then an update, the 10th revision of the draft, then within the next 2 weeks. That's our target. Questions, comments?
Thank you.
Good morning, I'm Xufeng Liu from Jabil, and I'm here to report the status of the T topology Young model. Close. Yeah. Here's a list of authors and contributors. Can we go next slide? Oh. We have went through the working group last call and addressed the review comments. So summary of the changes, we have done some text clarifications, so including some terminology references and some additional text. And also we did a couple of minor model changes, fixed some review comments. So here are the list of items we have done to clarify the text. So including the terminology clarification and also put the FC 2119 text in the terminology section, and we align with the latest documents, list of documents we have been using as a reference. So we also instead of repeat the tree diagram, we use the draft as a reference to show what we have been used in our draft for the tree diagram. And also we added a new section to show how do we do the augmentation for each technology specific models. So for the model fixes, one of those issues is from C-Camp Transport NBI design team, and they during the review they noticed that in the unidirectional interdomain link, we used to have a plug ID here on the link. So, but in the unidirection case, the domain 2 does not have anything to advertise for the link. So the plug ID is no good way to advertise that. So we move the plug ID from the link to the termination points. So this is the result we have been we have done. So we move the location, and everything else remain the same. And another issue from C-Camp Transport and BI design team is the during when we trying to implement this interdomain link plug ID, so they need to use a multiple discovery mechanism, and each of them desires to have a separate range. So we changed the type from uint32 to a variable length. So here are the changes. The top piece is the plug ID. And also we move to the bottom portion and make the type change. Another change we did will be the some common attributes between our model and our augmentation models. So we consolidate them together, put in here, so that the augmentation models don't need to do the repeated work. So here the changes we have for the name we put together here. Those are the changes. And so for the next step, we'll address any comments whenever they come. And then we proceed for the further reviews and for publication. That's it.
Any comments? How many people have looked at the latest version? That's a reasonable number. How many of you are looking to augment this model for in like CCAM? That's a pretty good amount too. If you are working on an augmentation, I'd really like you to take a look at the new section on augmentation guidance and make sure that it makes sense to you and that it aligns with how you're planning to use it, and that it will be useful for the next person who comes behind you to do an augmentation. This is really the last section that's holding up the document. So please take a look at it in the next, if you do it this week, that would be great, but maybe within the next, the week after IETF. And once you've looked at it, please send a message just saying, looks good. And after we get a few of those, we'll proceed. What would be even better, though, is if you say you'd like to see a change in it. So if you see something, an inaccuracy, that would be even better than looks good. But at least send the looks good. It's really important that our documents not only help the people that are currently looking at it, but the next readers that come along, and particularly something like this, which is foundational. We're hoping that it's worked on by people that are not in this room, and it's important that we capture the ideas so that they can benefit from what we know and what we understand. Thank you.
Thank you.
I'm hoping we'll have in the next 2 weeks proceed on it with a submission for publication.
Good morning, everybody. You guys hear me?
You really have to like eat the mic.
How about now? No. So good morning again, everybody. My name is Rakesh Gandhi, and I'm providing an update on the young data models for TE and RSVP. There are 3 drafts listed. So providing an update for the authors listed on the slides, and there were many contributors as well. So the agenda is as following. We look at the update we made to the IDs since last IETF. We look at the open issues and discuss next steps. So the first one is the TE model. So many thanks to Sergio, Italo, Carlo, Francisco for their feedback and lots of good discussions on the various changes that we made on the draft. Also thanks to multi-vendor team and IA for the continued discussion on the regular meetings. So there are four main changes that we made to this ID. The first one, the Nmda compliance changes. We added support for the bi-directional LSP protection and restoration. And then there is a change for the per technology bandwidth. So as you already know, the Nmda compliance, basically we remove the config, the part and the state branch. So you just see everything at under the feature now. And there is a state-only container that contains really the state related information. So bi-directional tunnel support added. So for each primary path, there is a reverse primary path, and for each reverse primary path, there is a reverse secondary path. So for the co-routed bidirectional LSPs, we don't really need the reverse path. So it can be auto-created that matches the forward path. So we added the protection and restoration feature. So there are parameters we added for the protection. There is a knob for it, the protection type like 141 or 14N. There are timers like hold off and wait to restore. There is a restoration config knobs as well as the schemes like pre-plan or pre-signal or pre-computed, and various timers for restorations. Again, the state information for this feature, the lockout, or freeze, or the roll, and also there is a list of shared resources, the tunnels for them. There are also action commands defined for protection and restoration. You have force a switch or manual switch action or clear those commands. And the last one is the per technology bandwidth. So now it covers the PSC, OTN, and LSC, as well as a generic bandwidth. So that's the update for the TE model. We look at the RSVP and RSVP TE drafts now. So basically the changes are the Nmda compliance and mostly editorial in nature to align with the changes we made in the TE model. So next steps for this RSVP draft is the base and extended it's stable. It is ready for working group last call. We do request the review comments and suggestions. And thank you. That's the update we have.
Questions, comments? Okay, I had sent mail to the list about references.
Yes.
Can you talk about that a little bit?
Yeah, so I think at many places in help strings, we do have, for example, for protection, it would say 4872 and whatnot. But we agree with you that we don't have it everywhere. So we should be adding those.
Yeah, it's really good when talking about configuration of a specific feature to reference where that feature is defined.
Yeah.
To make sure that all readers understand exactly what is intended.
Yes, yes.
So that's good.
Yeah.
Going back to the Yang TE document, the first one you presented.
Yeah.
You really cover three pieces in there. There's a base one, there's an MPLS TE
Yeah.
model and there's an SR model.
SR, yeah.
Does it make sense to, now that the technical work is all done, does it make sense to publish these as 3 separate documents so that they're separately referenceable? Generally, we try not to put different essentially technologies into the same document. And to be clear, what I'm talking about is a reformatting of the current work, publication immediately as working group documents, and then moving to the last call. We're not talking about a process reset or anything here.
Yeah.
It's really just a publication piece.
Yeah, so we did that for RSVP-TE. So we used to have 2, and now we have 3. And we didn't know at what point to stop because we can have 4, 5, 6, 7, and we look for your guidance. We're okay to have more documents, but then it's more work as well. So
that's right. You get more RFC numbers.
More RFCs and stuff, yeah. But
more gold stars.
Yeah.
Again, generally we try not to bundle different technologies into the same document. Be interesting to hear from the working group if anyone has an opinion. Think that it's good to split, good to keep the same. Why don't I ask for hands? How many think that it's a good idea to break apart the technology specifics into their own documents? That's a reasonable number. How many think it's better just to keep it all in one as it is? That's pretty clear. No one raised their hands, so please do the split.
Okay.
Immediately submit them as draft IETF-TEAS. If I think the names are pretty obvious, so we don't have to go through around on that.
Sure. Yeah.
Okay. Great. Thank you.
Okay.
Shufu from Dribble. And one more piece inside the draft, the TE types. Do we want to keep at this, or we want to spin them out also?
I hate to say the acoustics are here. It's actually really hard to hear. I think you said
TE types.
Out TE types, whether it should be in its own.
Right.
Is that it's a generic thing. Is there any reason why you wouldn't keep it generic in the generic document?
The thing is that because the T types will be shared between the tunnel model and the other like a topology model. So if we have update, it's fine to stay at this, but whenever we update types, so we have to update this document.
Well, it could be an update to, if it's an update, that's not a big deal because that's just an update. If it's a BIS, then that does become a problem because then you have to be revving models that you're not, revving a document that contains models that you're not really changing. Do you think that it's an update or do you think it's a BIS?
Well, I think probably sometimes we may want to add the new thing to the types. So I think it will be okay. So just do the BIS. I'm fine with that.
I caught, I think, parts of that, and the high order bit was you're okay keeping it in the same document.
Yeah.
Okay. Thanks. Moving right along.
Good morning. My name is Sergio Bellotti from Nokia. I'm going to present.
Sorry, just hold the mic in really close. Just take it out and hold it.
Okay. It's better? Yeah. Okay. Okay. I'm going to present a CTN information model. Okay. Just a brief background on how the model is structured. The model is structured by primitives that represent the network, the basic action needed to support a CTN network function. And then these primitives are characterized by object and properties. The objects are the real CTN resources that need to be exchanged on the interfaces defined in SCTN. Okay, the updates from the two versions This is our 2 version, because the version 3 practically is just the changing of the name of the physical network controller that is moving from physical network controller to provisioning network controller. And so the major update is from version 2. And the basic modification has been a heavy restructuring of the draft, separating explicitly what are the primitives that is related to the virtual network management, and the primitives that are related to the traffic engineering. This is following the characteristic of the interface on the CTN. So the virtual network that is mapping on the CMI interface, and the traffic engineering primitives that are close to the MPI interfaces. Then we have consequently refined the some part of the objects. So we added the virtual network topology, virtual network member definition, and we have refined tunnel characteristic and the TIE tunnel characteristic, TIE topology update, and general refinement in the object. And then, as I said, the change of the name on the physical network controller to provisioning network controller. So the structure is based on the separation between the virtual network primitives at SMI, in which there is no needed for detailed traffic engineering information, and the basic functionality is to translate what are the customer information, service information into the application in the virtual network service. Instead, in the traffic engineering at MEI level, the basic functionality is to create an end-to-end coordination between a multi-domain, and for that, and to create an end-to-end abstracted network in which the traffic engineering information is essential. Accordingly, there are 2 different definitions regarding topology. The virtual network topology, that is a customer view topology for a view at the control of the customer, and the traffic engineering topology that instead is based on what is the real provider network resources, and on which you can apply policy to decide the correct and the winning level of abstraction to represent the underlying resources. Okay, this is the new table that after the restructure that is mapping is describing the virtual network action primitives, so just related to the virtual network. So the virtual network instantiation that can be based on the 2 types as defined in the framework document of the virtual network. So type 1, that is one-to-one the set of member end-to-end links in the CTN, and the type 2 that is related to virtual node, the virtual link, so is described over the real virtual network topology. So in the modification, the virtual network action for modification, deletion, and path computation. Virtual network path computation, that is just exploring, just a priori exploration to compute network resources, just to have to prove availability of resources, and then the query and the virtual network update. In parallel, we define the related traffic engineering action primitives related to MPI. So with the traffic engineering instantiate, the modify, the delete, the path computation, that is an action between MDC and PNC to request path computation and obtain a related computed path. And the traffic engineering topology update for any changing in the underlying network that is providing from between the PNC and the MDSC. consecutive, we have defined, as I said before, new object that is the virtual network topology, and both for the virtual network and the traffic engineering topology that I listed here. So basically the virtual network topology definition and the traffic engineering topology definition. And here is the mapping of the primitives with the new object, and also the other one, and all the definition of the primitives mapping on the related object, with the clear separation between virtual network primitives and traffic engineering primitives. So, as a representative of the co-authors of the drafts, we think that the draft is now complete, represent all the information needed for encoding in the CTN contest, and so we think that we can be ready for last call.
Comments, questions? At the last meeting, there was a comment on actually a different document related to type 1 and type 2, and how different do they really need to be. In your document, while you define type 1, type 2, you don't identify different sets of information elements needed to support each. Correct?
Different information? No, that's in the sense that
it's the same set. So from the perspective of this document, it would be okay to use the same information structure for both, correct?
Yes, it's correct.
Okay, so it doesn't, the point I wanted to get to is that this document allows flexibility in the actual implementation,
yes,
of the mechanism or definition of the mechanism,
depending on the type
of either approach. That was what was discussed in the context of the other document we're going to get to in a couple of slides.
Yes.
Okay, that's good. So the plan right now is to move this document as a set with the framework and the requirements, to move those all together as a set through last call. So be prepared for that. Take a look at the documents. You can send comments before the last call comes out, but I think we just have to make sure that all the IPR disclosures are in, and once that's done, we're going to issue the last call.
Okay. Thank you.
Thank you.
Okay, good. Okay, good morning. Good. My name is Hami, and I'm going to present this new draft applicability of young models for ACTM. This is a draft newly adopted by the working group. So this draft actually explains how the different of the IETF young models can be applicable to the ACTM framework, including both of those controllers and the corresponding interface. So the the models are divided into a few different categories. The first kind of model is called customer service models, and we describe the application in the ACTM architecture called CMI. And then it is a service delivery model in the ACTM architecture, which is inside the MDSC, and it can be used as a kind of internal model. And finally, the network configuration models are used in the ACTM architecture in the MPI interface, and the objective is mainly for the multi-vendor interoperability. So this work discuss the applicability of those kind of specific data models that are under development, and we will have a brief review one by one. So here is a very brief figure of the ACTM controller hierarchies. And the first interface we are going to introduce is the CMI here. And the objective for this interface is mainly to provide a kind of service to the network users. And we assume that there are a few different young models that are applicable to this interface, including the L1 CSM to provide L1 VPN and a few of the VM models to provide the virtual network service. We also work together with the OPS area to see whether it is possible to integrate the L2 and L3 layer 2, layer 3 service model together. And the next,
Do you want to take question now?
do you want to ask now or?
I would.
Okay, please.
Okay. So my name is Michael Scharf. So on that slide, could you comment on the difference between the service model that you mentioned here and what a VN member is? Because I think this draft somehow doesn't clearly define what is the service model. For example, the L1 CSM, and what is the VN member model and how they relate to each other or whether they overlap. So I think there's some confusion in there. And I'm wondering if you could comment on that.
Yeah, to me, the VN is a kind of high-level description of the virtual network by describing this kind of topologies and a set of different tunnels, so we call this VN members. And considering the layer-specific issues, we assume that the L1, L2, L3 VPNs, they are some quite mature service and can be achieved by this kind of service models. So that's slightly different.
Yes, slightly different is not a precise definition of the exact difference. And specifically for layer 1, I think you have to work out, so what is this difference, why there's actually a need for two different things, and how a customer would, on the CMI interface, how he would really use this. So for example, how he would set up VM member, how he would set up a layer 1 service, and how the workflow works the implications of all this. And as I said, I think
there would
if you put it that way, you have to explain these concepts. And the document, in my opinion, is not in a good shape in that space.
Yeah, I agree on this. And I think we can have more offline discussion. Okay, the next slide shows the models and applicable to the MPI, which whose objective is mainly for the multi-vendor interop. And for this interface, we have achieved a few different functionalities, including the scheduling, path computation, provisioning, topology, and tunnel. So we have tried to integrate a few different young models developed from various working groups and coexist and interwork on the same interface. And considering the more technology-specific problems, so we have also OTN, WSON, and the FlexiGrade topology and the tunnel models to support this. And I think the current work is just adopted by the working group, and currently the content and techniques are quite stable, and we have reached common understanding in the authors team. And so this is a document that says how to build the ACT interface by using what kind of models. So we may need to update some text to better align with the latest ACTM framework after the working group last call, and we will together update corresponding reference, the description, and then we will request for the working group last call. So that's all for the presentation.
Any comments, questions? What do you see happening with the transport service? I think it was a document presented a couple of IETFs ago about transport service model, where a bunch of the text was merged into, I think, this document, as well as maybe a little into the framework. Do you still see a need for that other document? And I asked both you and any of the other authors of that document.
Yeah, are you referring to a kind of layer 1 transport service model?
I'm trying to remember the document name, so this is from memory, so I apologize if I don't have
yeah, that one applies for the MPI.
and it's not a kind of the customer service model. It's a kind of network service model. And usually, given the different layers of the network, there is usually a kind of client layer and the server layer. So, okay, better. So usually, given the multiple layer in the network, there is a client layer and the server layer in the network. So that model transport service is trying to define how the client layer describe their request. So it is different from the customer service listed here. So that's applied on a different interface.
Thank you.
Just in short comment and wording. So draft defines close relationship between Yang and NetConf RESTConf. In the future, it might be something different. Probably you don't want to specify in something that's going to become RFC that it must work over NetConf. Could be gRPC, could be Drift, could be, we don't know what's going to be. Right. So your focus is Yang models, not really.
Yeah, we are focusing on the modeling.
Yeah,
it has very specific text in the draft.
Right.
Yeah, stating a personal preference, I think we should stop at the Yang model and not say anything about how those Yang models are transported.
Some like pigeons.
Good comment, thank you.
Hello, this is Dhruv. I'm not sure whether they are the latest slides or not, but they are uploaded on the TEAS working group page, meeting material. So in case they are old, please refer there. I apologize for being late.
Sure.
Anyways.
And I don't believe these are the latest slides. We'll make sure that they get updated.
They're already updated.
Oh.
So they are on the slides. They might not be here on the...
Again, I did the download at 9, so I thought that was late enough. Sorry.
So if something is still not answered, the slides are there. So please reach out to the authors and we'll try to clarify where we are coming from. So this is the ACT and VN Yang model. We talked about the info in which we said that we would need VN primitives, which are a little different from the TE primitives. And then we also talked about the various Yang model in the previous presentation. So this is the VN Yang model for CMI. So let me introduce this a little bit. The focus is inside the framework document, we clearly define what is the VN service. And we defined two types of VN, VN type 1, type 2. And in service, we have the whole life cycle management. So we saw in the info model as well, VN instantiation, VN modify, VN query, VN compute. So all these operations that we would like to do it on the VN. So this Yang model tries to model the CMI and the VN operations that would be needed. So as per the architecture, we know this belongs at the business boundary between the customer and the network. And thus this model is aligned to the customer service model. The same concept that happens, that's been I think it's in RFC editor queue now, the ops working group, the model classification thing, how we have a customer service model, network delivery model, network configuration model, and the device model. So this ACT and VN Yang for us is at the customer service model. What all information do we want to put in this model? It's all the information that a customer would need. So talking about how the access points, that is how the customer sites and the provider networks are connected, that's where the access point and VNAP concept comes in as per our architecture document. When we define a VN, what are the properties we need to put? That is, what are our endpoints? What are our VN members? How are they interconnected to each other? What are the constraints, policies, and things like that? And most of the time, these things apply to the VN as a whole, and it applies to all the different VN members and different interconnections that I may have in the site. So the main point is that we want to give a view to the customer based on how he sees the VN, rather than how the VN is actually achieved inside the provider network. So what all the updates that we did? We made sure that we are aligned to the framework, because as you know, there were recent changes there. So all those changes are taken care of. making sure that the VN types and VNS types are well handled in the document. So we made those as a separate feature in the Yang, and where we need to define something VNS type 2 specific, that's enabled under the that feature. And info model, which we saw, where also we kind of differentiated between the VN primitives and the TE primitives. So this model focused on the VN primitives part of the info model. And the Nmda things are also handled in the document, the latest update. So just a little bit of a recap so that we can agree on this kind of model, whether this kind of model is needed or not. We know that in our architecture document and in info model, we have talked about this VNS service, and we say there are two ways to operate the VN. We could do it very simply by talking only in terms of edge-to-edge links, which is type 1. So I have customer sites. I simply say how these customer sites needs to be connected, and those are nothing but the VN member. And how these VN members are actually instantiated, all that details are kind of hidden. But it's a very simple view of the network to our customer. In some cases, there might be a need to show a little bit more detail and give a little bit more control to our customer. That's where the VN topology comes in. And as was discussed in the previous, that VN topology and T topology are a little different. VN topology is just the view of the topology to the customer. Here as well, we have two modes, whether the topology is pre-negotiated or pre-configured, and whether we allow changes to it or we don't. That's where the 2A and the 2B comes into the picture. But overall, the concept remains the same. So with this model, we wanted to make sure that we are able to operate on both the types of topology. And as per the info model, where we said that most of the operations and things are same, whether we do type 1 and type 2, and you will see even in this Yang model, that remains to be, that's quite true here as well. And this is just an illustration of how the VN topology will look like. I think the main focus is at the CMI level. That is how the interaction is between the MDSC and the CNC. So customer comes in, tells, I would like these sites to be interconnected, and this is my VN, these are the endpoints, and these are which kind of connection, whether I want a full mesh, whether I want some hub and spoke kind of a setup, or what is my policy constraints, all those things as a whole. So the main concept here is that we are able to define a VN as a single entity as per our framework, as per our info model, and that's what is shown to the customer. And in some cases, the customer would configure it. In some cases, customer may just want to view how a particular service, what is the VN slice that I am getting, and that information is modeled in the same way, right? So, once you have the customer view of this VN, of course, the real work has to be done by MDSC in mapping that particular view into the real part. Let me start again. So we have the customer view coming from the CMI, and it's the job of the MDSC to translate that view into the real provider network. What set of tunnels that I need to set up? What boundary nodes should I use? How do I do the stitching? All those details are kind of hidden to the customer. So in case of a multi-domain topology, we only talk about the final two endpoints. All the details about the domains and all are completely hidden. But if we don't have a model like this, then what would need is that we would need the customer to be well aware of the domain topology, the domain boundaries, the peering relationships, and then only he would be able to establish and have some control over how I want the various connections to be done, which makes it much more operationally harder as well. So we believe that having this this entity called VN, which is a core part of the ACTN architecture, and having a model that deals with VN as a whole has various advantages. And it is definitely a different model than the other models that are available in the tunnel as well as in the topology case.
We have Igor and Q remote.
Okay.
Not sure if I have to hit
Okay.
the button.
Can you hear me?
Yeah, you're good, Igor.
Oh,
Go
okay,
ahead.
okay. Good morning, guys. Sorry that I couldn't make it to Singapore. So my comment is that, Drew, whatever you discussed and described, this is exactly what Topology can do right now. Okay, the customer can configure the abstract topology, can negotiate, can get the view, and it has nothing to do with the native topology.
Okay, to answer that question, of course, we have, it's a part of TEAS work. We believe that the TE topology and TE tunnel model are very much needed. But the idea here was that should we use the same model, the model that we currently have for our device and our for network, also to face towards the customer. So far in IETF, we kind of, at least that's the feeling that I have always got, that having a separate model and separate abstractions have always helped us. Having this kind of layering approach has helped us, that we have a device, let's take L3SM, for instance, dealing with the different things. You have VRFs, you have this thing, and at the service layer, we focus only on the customer view. Of course, theoretically, we could use the same model at all the three layers, and I agree that abstract topology model can deal with some of the things that we are talking about here. But let's take an example that if I use abstract topology to configure the VN topology type 1, and I come to the VN topology, I say I would like these different kinds of these interconnected links. I can set a lot of properties here, but some of the things that we are dealing with, like how the policies needs to be described, having a VN as a construct helps us quite a bit. For example, to say that I am going to use this service maybe for VoIP and I care for delay optimization, I could easily set that as a policy for my VN, and all the details are hidden to the customer, and it becomes the job of MDSC to further translate it. Doing this as a part of a link property becomes a little harder to do. So it is theoretically, I completely agree with you, it's possible, but we need to make a decision within the group that do we believe that the same model should be used throughout in every layer, or should we have a very specialized model dealing only with the customer view, with the customer operations of this thing. So I think the crux of the debate comes back to that point.
So if you can point out what exactly cannot be done with abstract topology, why do you think that this is like the same model that is used by customer and by the, for example, MDSC? In our view, it's just different levels of abstractions, but otherwise they are completely same topologies.
I can definitely, the one example that I gave about the link optimization criteria, that's one. But I think instead of we talking about individual this thing, I think this is much more of, in my view, more of a philosophical discussion that we need to agree on, that should we try to reuse the same model in every place. And so that model has to satisfy the properties of what the device needs, what the SDN controller needs or the MDSC needs, as well as what our provisioning network controller needs. Or should we have a more specialized model which hide all the details that the customer does not care for? And one more key point is that when it comes to actually configuring the topology, which is where the VN type 2 comes in, we do not define nodes and links at all in this model. So there we completely refer to what is there in the T topology model, abstract T topology model. So when it comes to using your model, it's definitely needed. But the idea is that should we have within our modeling, in so far in architecture and framework, everywhere we have a concept called VN. So shouldn't we have a VN Yang model where the customer can express the architecture, the framework, and those things also? Or should we say, though theoretically they exist in your documents, but when it comes to modeling, go back and do it as a tunnel or as a link or as a topology? I think that's where we are coming from.
So Drew?
Yeah.
Generally in this group, we try hard to reuse the mechanisms that we have and to define things in a generic way that we can do layer upon layer upon layer. And when you're doing different layers, one layer is a provider, and the the layer above you is your customer, and then
Yes.
we iterate over that.
Yes.
So we often do end up with models that, from a philosophical,
Yeah, yeah.
to answer your philosophical question, we try to have the same models
Yes.
to do that. Now, you do bring up other points where there might be some technical details that are not covered in the current model. That would be good to go through and say, give a specific definition of here's what we can do, here's what we can't do. And then rather than having sort of an abstract philosophical conversation, we can understand where the real limitations exist, and then answer with understanding of the specifics, whether it's better to have a new model or to reuse and augment the current one.
Okay.
So maybe it's a little early to answer
Yeah.
the question, but from the question on the design philosophy, yes, we do want to reuse. And we do want to come up with mechanisms that support arbitrary levels of layering and stacking on top of each other, where the layer below you is your provider, the layer above you is your customer, and we can just iterate it over and over again. That was one of the changes I had actually requested in the framework document. And the funny thing is, I sat on was it? No, I'm sorry, it wasn't a plane. It was in the newcomers meet and greet. Someone said, "Oh, you work on TEAS. I need to solve this problem." And it was exactly the thing. It says, "Tell me how you do it." I was like, well, "There's a new figure." So it's a really important concept.
Yeah, my name is Michael Scherf from Nokia. I just want to back what Igor said and all the other comments. So this is perfectly true. So it's not at all clear to me at this stage why another model is needed. And specifically, one of the problems is the latest changes to the framework document where you show a hierarchy. You actually end up in your situation. You have the TEAS models below, then you have the CMC, then you have in the next layer on top, you have again the TEAS topology models. So it's not at all clear why you need another model in the middle. And in that specific case, also keep in mind whether the relationship between the MDSC and the CNC is a business relationship or not. That's not at all clear. In some cases, yes, this can be an external interface. In some cases, this might be an internal interface inside the operator between different layers. And in that specific case, for example, the amount of attributes that you expose can be different. And you will, in my opinion, in many cases need quite a significant number of the attributes that you have in the TEAS models already. For example, in the existing drafts, you don't have anything on diversity. You don't have SRGs in there. That's a really relevant use case. And if you go down that road, you will probably end up in adding more and more attributes to this VN model that we already have in the existing one. So it's not at all clear as of now why a separate model is needed, and all the other things that you have on the VN. So this is all things that can be sorted out by implementation. Also, for example, applying a policy to a set of tunnels. This is something we don't have to sort it out in this specific Young model. There are other techniques how to do this. So in a nutshell, it's not at all clear as of today why we cannot reuse what is there, except maybe that if for some of these use cases, we might not need all attributes in the TEAS tunnel model, for example. But that's a fair point. We could specify that certain attributes might not be needed, and actually simplifying things would be good in that case. Thanks.
So I completely agree with Michael, what you said. See, so our focus here was where the business relationship comes in.
Yeah, but there's this is only one case that it's internal.
Yeah.
As I said, in the framework document, there's a clear other use case where this is not external.
And I agree. And so the idea there was that since this model further refers to the topology model and tunnel model, it abstracts things. And when you need details, so if you are using as a part of your provider, you want more details, it has a reference so that you can go to the topology model, or you can go to the tunnel model and find those details. So the abstraction is maintained at the same time. So for us to say that since in some cases you would need more details, let's not have an abstraction, is something that where we are having a little bit of debate.
Yeah, I think, Lou, as you said, I think what you are trying to do here is that, why T tunnel model and topology may not satisfy, customer expressing their service. That's why we introduced VN concept. And we actually reuse most of the construct that T topology used, especially VN type 2. We don't reinvent the wheel. We just reference the right tunnel and then topology. So as Igor said, we are reusing the, semantics already. So I think VN concept, however, is a very, useful concept, and I think required concept from customer perspective. That's why we are introducing this. So we're not reinventing the wheel. So we're going to make it a little more, clarification in the new document why we think that VN concept is needed on top of TE tunnel and topology.
I don't think there's disagreement that a VN concept is needed. It's a question of how to realize that concept.
Exactly.
I don't think there's a disagreement on that a virtual network's a good thing. I mean,
right, and also
that is what a TE topology gives you with its layering. It's also doing virtualization.
Correct. And also, in answering your question, diversity, customer don't care diversity. They have SLA. Provide my delay, and then my loss is this budget. You take care of it in the network. That's network's job. We don't express diversity in the VN level. So that's answering your question. Customer don't need to know, Yep.
Okay, on that one, I disagree. Also in the use cases that I have, diversity is relevant to the CNC. So you have to find a way to put it in there. There might be different ways how to do it. But this is a request from me to allow diversity information exposed to the CNC. And if this is not possible, why do we talking about traffic engineering?
Actually, diversity.
That's exactly distinction. That's exactly distinction. We're not doing traffic engineering. Customer have SLA. They express through VN model. That's all.
I think you're highlighting a good range of what happens in use cases. Every user is a little different. For example, in my experience with transport networks, being able to tell your customer that you use a diverse path is table stakes. And if we presented a dynamic interface that didn't include that, they would never use it. So, but that's just, that one use case. There's other use cases where I think you're right, where the customer doesn't want to look at that. They just want to get this, whatever the service is.
That's right. I mean, our main assumption is CMI is a demarcation between external customer to the networks. That's our main case. But as Michael said, there may be other cases that you indicated.
Mine is an external one. The case I'm thinking of is an external customer.
Right.
So it's a different customer, and so it has they have different requirements. So I think what would be really helpful, and I think the authors can come back and say, yeah, this is crazy, or too much work. What would be really helpful is to take the TE topology model and see if you can just augment it to give the extra things, extra control knobs you think is important. And the other thing is there's already a lot of presence and features in the base model, so you don't have to use everything. And if you find that maybe there's a couple of containers or leafs in that model which are required, but for your use case really should be optional, maybe we can change that at this point and say, well, rather than make it a required node, let's make it an optional node. Remember that Yang already gives you the ability to not use everything that's there, not everything in the model.
Yeah, I agree with that statement, but I think VN concept is higher concept than TE tunnel concept, so I don't think we can really
I specifically
augment.
said TE topology. Excuse me, I meant to say, I have no idea what I
Okay,
actually
only
said. I
topology,
meant to
right?
say.
That's right.
One thing that I kind of found with T topology, maybe you could also correct if I had made a wrong assumption there. So when we are doing T topology, if it is a very simple, as we said, single node topology, if a customer is just expressing that, or end to end, it's pretty straightforward. But when it comes to, say, I want to, like what we do in type 2, that the topology that we want is a little bit more details are exposed. Then also on that topology, further setting, what are my hub, whether I want to do a full mesh, whether I want to do hub and spoke, and having little bit more control. I kind of found that that's a little bit messy for me to do. It's very simple when the abstract topology that I want to define is very straightforward. Link, link, link. It's up to you. How do you translate this link into further details? But when I have a topology and I want customer to control that, oh, by the way, these two guys should talk and this guy should not talk, whether I want full mesh, hub, spoke, who are my endpoints, who talks to who, what are the properties, how do I optimize, like for example, giving a link and assigning a bandwidth is straightforward. I can match. But when I want to say, I want to optimize this VN for delay overall, those properties kind of get lost because the model is very good at the device layer, at network layer, but at the concept of optimizing the things as a whole kind of lacked. And that's why we thought that we can start from the top downs rather than modifying things from below. So we could do that exercise with you and see whether that's the right approach or not.
It would be really useful if you go through the exercise and point out where it's lagging. I still think it's a question of not having a well advanced tutorial for the topology model. There is a document out there that should give you more guidance on how to use it. But whatever you have mentioned so far, that's still that's possible in the TE topology model. I don't buy the statement that it's hard to do it with the topology model, but if you can go through that exercise with the topology model others and figure out where it's lagging or where it's difficult to do those sort of abstractions, that would be useful.
Okay, just queue because we're mixing local and remote. We have Daniele, Igor, Jeff, and then.
Okay, Daniele. Actually, here the problem often is not what is missing, but is what is too much. In the sense that the guy sitting on top of the MDSC often is an OSS, is a provider that just provides connectivity between endpoints. They don't want to know anything about tunnels and topology. They often say, I just want a connectivity between these points with these characteristics. That's it. That's why the VN concept, the VN model, it's very thin, have you seen? It's nothing very big, like a complex topology, a complex bunch of tunnels. They don't want often to deal with multiple domains, multiple technologies, just connectivity with given characteristics between points. And the VN aims at solving this very simple issue, hiding all the complexity. This was the main goal.
I think we talked about that there's a range of customers and a range of use cases. Some are very abstract, some are very detailed, and we really want a solution that supports the range as opposed to just picking one or the other. So if we have the case where we have a solution that's only very abstract, well, clearly that doesn't support the middle. If we have something that's only very detailed, that clearly doesn't support the middle or the end. So we have to figure out the right way to come up with something that supports these range of use cases and range of solutions. You want to respond, or?
Yeah, very quickly. The point is, in many cases, if you say to that customer, deal with the topology, he would say, no, I'm not going to do I'm not going to do that.
Right, but
this is the point.
You could use the topology model that all it does is give endpoints. And that's, I think, the conversation that Ivan was suggesting happening. Igor's next, then Jeff. Igor?
Okay, so one thing that I wanted to say is that basically optimizing abstract topology, it's a single attribute. So you can say optimize it by delay or optimize it by cost, and that's all is needed from the client point of view. And configuring, for example, a single node topology or a mesh link topology, it's the same exercise. It's very simple. So I would like to see Dhruv's results when he's trying to say that it's too messy to do this. I would like to see what exactly is messy.
So I think this is an exercise for us. We'll take it offline.
Sure.
Yeah, and I think it's really important. It's really important to look at it from address Daniele's comment of is there too much that's always required versus
Yes.
optional or feature set?
I think some kind of comparison between this is the JSON message if I use this, and this is the JSON message if I do this, and let's compare what's the way of
Right.
that could be done.
Pay really close attention to nodes that are mandatory and nodes that aren't.
So I think
Name, please.
Justin Sir. So I actually was a customer rather than being a vendor. So it's ability to express particular constraint. If you work with banks or hospitals, physical diversity is a CNC concept. It's a business logic. When I was a customer, I would ask you for layout of your cables and the way they live. So you really need to provide ability to express this. Does it have to be mandatory? Absolutely not. Most people will work with you on level of SLAs. I need you to be able to recover within 50 milliseconds, and you decide how you do it. But for those who need this should be optional and should be there.
Yeah, and I think it exists right here. I'm not sure whether you guys can see it or this. Those things exist there, but it's not done at the per tunnel level. Overall, we kind of say that for the whole VN as a whole, make sure that all VN members are diverse to each other, so that we are able to make sure that even if something goes down, some other person can take care. So the whole idea is doing the same. I cannot disagree with the fact that yes, the same can be easily done by T tunnel and T topology. The only part where we are disagreeing is it too complicated? For example, if I have a full mesh 9:9 connection, I make a change. I don't have a way to say that I'm making a change on a VN as a whole. I usually have to go to each things and make the change. So the main question for us is, can we make this a little bit easier as well?
Okay, Igor, hold off until Jeff finishes.
So again, it's about abilities and expressiveness. You could use English to express Shakespeare or stupid joke, right? So you want to have the first one to be able to express what you need.
Yes.
Okay, Dieter, then Igor.
Dieter Bell, Nokia. Specifically looking at your VNS Type 2 model, I really would like to understand why the T topology model cannot be used to describe what you need for this purpose. Because specifically when we developed the T topology model, we were looking at those kind of topologies, and I think the model is perfectly suited to describe these topologies.
And we reuse the T topology model by maintaining a reference to the T topology created there, but only because, as we said, the VN is the same irrespective of whether you use type 1 or type 2. That's there. So the whole idea of, even if you have more details about the VN topology, that you go and configure using the abstract T topology model. But what are your VN members? What is the policies based on which this VN is created? That we are maintaining in this model. And then this is not just configuration, it's also operational. So operationally, if I want to know how my VN as a whole is working, I could easily figure it out from this particular simple view without going individually into each tunnel, each link, and each status of everything else in my topology. That's where so let's have this discussion. Do I still have time, or? Yeah.
Then you have like 3 minutes.
Okay. Igor, go ahead.
I guess Igor is not in queue.
So let me try to, I think most of the conversations we have kind of had, this is basically trying to go over that why having a separate customer service model is useful. Most of the points we have already covered. Some of the further discussions that we are having, which is that having a telemetry on the VN as a whole, or how the VN can be mapped to the service model, which is in the further discussion. So that's also, especially the last point, that is something that we may not have covered so far, that in all cases, we do not expect the customer to create a VN explicitly. Sometimes the VN is created automatically. For example, if a customer is using an L3SM interface and providing the details, but automatically, based on the L3SM requirement, the site information, the VN could be created. So you don't use this VN model to actually instantiate it. Internally, MDSC does all the work, but we give an interface back to the customer. So the customer who created via L3SM service can still find out how the provider is making sure the same service is running. And that kind of information is quite useful as well. So it's not just configuration. Some other services that are documented in the ACTN requirement document, as well as in some of the use cases, have been the VN compute, that how doing the computation, the pre-instantiation, and getting the view that what is the VN that I'm going to actually get before I actually instantiate it. That's quite useful for a customer to make a lot of interesting decision. The same can also be done, for instance, by using path computation API, which is just adopted. But again, where we are coming from, is there a easier and simpler way to do the same, especially towards the customer? That can I ask the whole VN how to be computed as a whole, rather than giving separate path computation API request and having much more complicated computation. So having a VN as a whole entity in a Yang model, according to us, was quite useful. Another thing was the multi-source, multi-destination problem, which has been, I think, discussed in the info model as well. This is something not to be confused by P2MP. This is an interesting problem that some of the data center operators asked us to make sure that this is a part of our ACTN model, in which suppose for a data center, any of these destinations can host a particular service, and he would like to know from the customer or from the MDSC that where should I host it. And instead of like doing computation separately and then picking one, we simply provide this information to the MDSC. By the way, any of these 3 destinations will do. You tell me which one I should use for the service. And later on, monitor that destinations as well, so that if the path to that earlier selected destination is no longer meeting my SLA, which other guy can do that, so that I can also move the service there, as well as you can also make changes to the VN to support this. So this is also some innovative things that we can do if we have a VN as an entity that we can expose to our customer. And mapping, I think Danieli will cover a little bit more, that how VN maps very easily to L3SM, L2SM models as well. Just to summarize, I think according to us, this is useful. We'll further go through that exercise, that what we have agreed on, that how this T topology versus this model, and see if some of these things can be done on this. At least we have had some conversation regarding the multi-source, multi-destination problem, the VN compute problem with some of the authors, and we do realize that it's little hard to do these kind of things on the abstract T topology model. This is as you can see, the Yang model is not that complicated. We have the access point, VNAP. These also helps us to map to the L3SM site IDs and L2 VPN site IDs from the service side, which I think will be covered by Danieli, as well as you have the VN. In some cases, if you have the topology created, you can make a reference to the T topology model. You have concept of what are your VN members. In some cases, we want to give control to a customer on the VN topology, what path should be taken. So again, this is not the provider view. From the customer's view, what path should be taken, those information can be configured, and it's up to the MDSC to further translate this customer view to the provider network, what needs to be sent to the domain topology and the PNCs, etc. The concept of multi-source, multi-destinations is covered, and all the other properties are at the VN level. So I think that's one of the key things that we wanted to do, to have like policies or have optimizations applied on a VN as a whole, rather than individually on links or tunnels. Okay, so we wrote this document with the philosophy of customer service model, that having a separate model might be useful in some cases, and where more details are exposed, then the T topology model and the tunnel model will satisfy that purpose. But even if that is done, this model has that relationship and that references, so it becomes a more like an ecosystem of models, rather than use this versus this. Rather, they all work together. That's where that's the view that we had. We feel that it also works very well with the T Yang model and the other models that are already existing by having simple relationship. And let's see where this work takes us.
Yeah, I think we have given you a homework exercise before we can discuss the working group adoption. But obviously, we need something that sits to the customer interface. It's just a question of what's the right definition. So thanks.
While we are waiting, blue sheets, who hasn't filled in the blue sheets yet?
Where is the second blue sheet?
There's one in the front here.
Does someone have the second blue sheet? Oh, both are there. Okay.
Good morning. My name is Young Lee. I'm going to present Yang models for performance monitoring telemetry that can be applied to T tunnel model as well as a VN model. So this one is basically from customer view. Customer has some concerns about their performance data of their end-to-end tunnel from C to C. Or if you have a more than just a C to C connectivity, you may construct virtual network, may have multiple locations connected together. For instance, 10 data centers, they are interconnected together. They want to see how their key performance data is performing, so that they would be able to react to that data. So this is actually one of the key requirements specified in ACTN requirement documents. Operator want to be able to see data they want to see without getting tied to detailed levels of multi-domains and things like that. And also we have a use case document which is written before this ACTN work has triggered. They have very clear requirement that they don't want to be bombarded so many data, but they want to be able to see the abstracted performance monitoring data, such as delay and packet loss or bandwidth utilization of that nature, so that they can react to, interact with the network provider for mitigation. So from last version, we added utilization percentage, which might be very useful for customer to just know, instead of they calculate based on capacity and then utilize bandwidth. So we just add the percentage. And we have a two module, IETF TE KPI telemetry, and also IETF ACTN TE KPI telemetry. Both of them are Nmda compliant. Given the controversy of ACTN VN, I think this document itself can prolong without ACTN VN, if you will, because we have two modules. So basic idea is that customer can configure some grouping operation of some performance data they want to see, and then they specify they subscribe to such data, and then basically MDSC basically translate that into domain level and LSP level, and then concatenate that to give end-to-end performance data to the customer back. So that's basically the idea of this draft. As I said, we have two young modules. One is TE KPI telemetry, simply augments TE tunnel. And another one is ACTN VN TE telemetry that augments ACTN VN model that Dhruv just presented. So the purpose is same, but different level. So TE KPI telemetry model provides TE tunnel level performance monitoring. This is actually C to C data, and then they are depending on the operator to provide P to P tunnel data, so that they understand how their end-to-end VN member is performing. And we also have some scaling intent configuration for auto scaling in, scale out mechanism built in this model. Likewise for the other model. Let me just focus on TE tunnel augmentation model, because given the controversy of ACTN VN, let's hold off telemetry for that until we resolve the issue. So let's skip that. So scaling intent is basically allows a grouping operation by the customer of various performance data and react accordingly. Basically, it has a scale in or scale down mechanism for TE tunnel that include a list of parameters to monitor, and then logical operation to be applied to the monitored parameters. And it can give thresholding time and cooling time, so that they understand the nature of this the performance data. One example is if I have TE two-way delay more than 50 milliseconds and packet loss is 1% above, then it just automatically scale in TE. So this is the Yang model that we basically specify. It's just augment T tunnel model, the various of data as you can see on the screen. And then we have a mapping with T tunnel reference, what this data is referring to in the T tunnel model, so that customer understand this belongs to which tunnel they are referring to. Yeah, and then we have a scale in, the grouping operation, scale in, scale out operation augmented again to the T tunnel model, as you see on the right-hand side. Mike, you have a question?
Yeah, actually, I have two questions. My name is Michael Scharf. The first one is about technology specifics. I think I've mentioned before that this list contains some technology specific entries, such as packet loss. But the general question is, so, I mean, we don't fully know how this model would be used. It can be applied to different technologies. Telemetry or whatever that is about could apply to different technologies. So you will have to think about how you deal with different technologies. And how you add the corresponding attributes. And it's not clear to me in that model how you deal with this, because you probably need different augmentations or things like this. So you have to think about that. And it's not clear to me in the specific draft how you do that. The second comment is on these intent things. So you've already shown some examples. In general, for the scaling things, or there can be things beyond scaling, by the way. Do you really think that you can hard code here all different policies or all different business logics that would be required in such cases? I'm not sure if it makes sense to put this in this Yang model, to be honest, because there can be very different conditions. It's really business logic, and I'm not sure if you really want to encode all different conditions here in a Yang module. That this might be pretty hard.
Yeah, I think we're taken. So I think about the packet loss. I don't know. Maybe we need some guidance from. We thought the packet loss is generic, but a lot of customer, they know packet loss and delay and bandwidth level. But optical maybe vendor may have BER. So maybe we can take up packet loss. I don't know. What is your opinion on here?
I think you answered your own question.
Okay, then this can be augmented in CCamp, right?
Right.
Ethernet, and then maybe layer 1, layer 0, maybe it's a BER. So we can augment that. Okay. And then second question on the thresholding and the scaling in, scaling out mechanism. I agree with you that that's not really telemetry model in itself. So either we take it out and then pursue a different model if people think it's useful, but we can think about that. Okay? Okay.
So, sorry, I got distracted by echo. I'm not sure if you just said this, but one of the things that would be really useful, and we talked about this, I think, at the previous meeting, is on the parts that you're augmenting TE topology that are truly generic, it might be valuable to bring this immediately into TE topology before we finalize it. Okay. So if we can send some comments in like the next week or two and say these pieces of telemetry information are generic, send it to the list and propose it, and then we can have a quick discussion and figure out whether we bring that in so that it's part of the core. I think there is general agreement that telemetry is an important part of any model nowadays. So
I mean, some of the leaves that you're augmenting for TE tunnel, they seem to be already there in the base model. So
no, your model has only link telemetry, not end-to-end telemetry.
So the state leaves under a tunnel that you're augmenting, they're
right.
already, some of them are already there in the base model.
You're right, actually. So you have a one-way delay.
Go through an exercise and figure out which ones are missing.
Yes, but I think that model you're referring to is, if I understand correctly, more link statistics rather than tunnel statistics. Maybe Shufeng can clarify. If I read it, it just augments some of the RFCs and GMPLS on that. So
statistics per link in the topology model.
Right.
And for the tunnel as a whole, for the whole path, there are some statistics.
Right.
But yeah, it's essentially the same. For the whole tunnel, there are some state leaves that you can use.
Right, but your tunnel is a per domain tunnel, right? Correct? Within one domain, you have a TTP
but you are augmenting the TE tunnel.
Right, but this one, we are talking about C to C tunnel, so a little bit different level.
I hate to do this to my co-chair, but we actually are over.
Okay.
So this seems like a good...
yeah, I look into that offline.
But yeah, so that would be a good discussion for the list. Jeff? I don't know if you have something quick. But we can try to
Yeah,
wrap
quick.
up.
So from usability perspective, with MDMA, now you could compare your operational state derived from telemetry into your intended state. So a few weeks ago, we've published new draft where we define number of RPCs and new action called compare.
Okay.
So by using this, you can define source, target, filters. It would be very useful to be able to compare your operational state from telemetry, derived from a telemetry into what it should be and take some actions.
Okay. Yeah, so I wrap up. So we have a two module here. One module is for T tunnel. So we clarify that. I think that in itself can be adopted as a working group, if you will. But
Again, I'd propose,
right.
Propose as an addition to the current base model. We're not done with it. It'd be better to do that rather than do an augmentation to it, unless we really believe that people aren't going to be interested in it.
All right.
So if you can propose that quickly on list, we can get that brought in pretty quickly into the working group document.
Okay. All right.
Hello, this is Daniele presenting the traffic engineering and service mapping YAM model. This is a very simple model that is used to create a relationship between a service and the infrastructure, where the service can be, for example, we tried to make it to cover all the different possibilities. We have L3SM, L2SM, the new layer 1 CSM, and it can be easily extended to support further services. On the other side, on the infrastructure side, we have support for TA tunnels and ACTN virtual networks. This can be easily augmented also from that side. This is a document that falls under the ACTN umbrella, but doesn't necessarily need to be implemented in an ACTN environment. You can, for example, decide within a single domain without any hierarchy of SDN controllers to have a layer 3 VPN binded to a TA tunnel. Updates since the last version. First of all, the scope. We made it clear that the scope of the document is limited to a set of domains under the same network operator. We received a comment about the applicability of ACTN to multiple domains with different operators. This is not yet covered by the document. It's out of scope. We added the support for the new layer 1 service model, the one that has been presented in CCAMP, and added consideration of different modes of operations. You will see in the next slides. Okay, so these are the old ones. Sorry about that. We had in the latest version we had some examples on how to use it, but never mind. You'll find it in the meeting material. So let's go directly to the different modes of operations. We identified 3 of them. This doesn't mean that they are the only 3 available. Some other cases, some other modes can be discussed and added. The 3 that we focused on are the binding of a service to a new infrastructure. This means that when a service is requested, the infrastructure to support it is provided as well. For example, I want a new L3 VPN between 3 endpoints with 100 gigabits allocated. 3 tunnels or 1 VN will be allocated as well. This is something extremely common and useful in network slicing, for example. The second one is selection of existing infrastructure. This means that when a customer asks for a VPN, nothing new is created, but a choice is performed among the different tunnels and virtual networks already available. The latter allows for the modification of existing tunnels and the virtual networks, where the simplest case is just increasing the bandwidth reserved for such tunnels. Here we have an example of the flow. Basically, the service, like for example, an L3SM model is used to request a service at the MDSC level, also on top of the MDSC. The MDSC translates the request into a setup, selection, or modification of an existing T tunnel or VN, and cascades the request to the various PNCs under the form of a T model, for example, a T tunnel. Then the PNC uses the device models to actually implement the configuration on the nodes. Like for example, create a VRF, bind the VRF to the given tunnels. You have a specific question on one of the slides?
Yeah, specifically on that slide. So no, on that one.
This one.
So my name is Michael Scharf. So a general comment on that draft, but also specifically on that slide. What is definitely missing in this whole draft is a discussion how this would really work in realistic use cases. For example, the topology that you show here doesn't show P routers, it doesn't show PE routers, it doesn't talk about what IP tunnels you're talking about. You put an optical network somewhere in the middle between two IP nodes. In fact, actually, you have an overlay of the IP network on top of the underlying optical network. So this picture here is really unrealistic. It even contradicts another use case or another way to do this that is listed now explicitly in the framework document. So before talking about details here, I think the first thing that you have to do is you have to show these kind of flows for actual technology, talk about what you would map, start with an IP topology, for example, add the P routers, add it for multiple S and things like this and discuss that, and then take it from there. There's certainly valid content in here, valid ideas, but the examples that you look at are way too simple and unrealistic.
This is the old set of slides. We updated it, and you would have been happier with the new slides. I'm sorry, we sent them too late.
I've looked at the slides at the data tracker. It's the same comment. Please add realistic topologies, realistic use cases, multiple IPAS. Put it explicitly define what IP tunnels you're mapping to, and then start it from there. So this is not at all addressed on none slide that I've ever seen. So you have to add a slide where you have P routers, PE routers, and things like this, ASBRs at the IP level. There's a single layer, start with that. And if you want to add optics, then make a real multi-layer use case out of it. Look at the ACTN framework that talks about how this could be done and start from there.
Michael, before you go, did you look at the draft or just the slides?
Draft to slide. Draft to slide.
Is your comment on the slides or the current version of the draft?
It's related to both because the draft even has less examples how this would be used.
This is Young. Can you provide an example? What you are referring to?
I'm referring to that specific slide. This is not realistic. In the draft, there's no example at all on what you actually want to map to. Right. I'm asking for put in an example for a layer 3 VPN over 2AS. Explain how you want to map the layer 3 SM model to an actual IP tunnel topology. Add that.
Yeah, Michael, so my point is, wait, can you provide an example to
Michael
us?
And Young,
whatever you
yeah, we're actually very over time. It would be great if you would spend a few minutes with each other this week so that you understand the comments and then address the comments. And I think once those comments are addressed, we can talk about the next step for the document.
Yes. Yes. Basically, if you send an example you would like to see covered on the list, we will work on that.
Igor, you're up. And we are running behind, so anything you can do to help put us back on schedule, we'd appreciate it.
Sure. When it comes to me, I'm going to say, right. So why do we need this document? Why we wrote this document? Basically, the reason is precisely because people like Dhruv keep complaining that the models are too complex and the documents are too esoteric to understand what could be done and what kind of use cases could be addressed, what kind of problems could be solved. And unfortunately, it's not just Dhruv. We also hear the same things from operators. Okay, so that's why we decided to write a document which discusses basically the models, concepts, constructs, semantics in great details, and also discuss multiple use cases that could be resolved. Next slide, please. Okay, so the document includes basically three sections. One is described in the T topology model, another T tunnel, and the third one provides use cases which combines the two models and describes how the common problems could be solved. Incidentally, one of these use cases is VNS, how you can configure VNS with an abstract topology. Next slide.
Go ahead, Igor.
Okay, it loads. It takes time. So this is the second time when we presented that. The first time was in Prague in IETF 99, and since then, basically our goal is to keep it aligned with the latest development in the T topology and tunnel model. So, for example, we included various new concepts that were introduced, such as dependency tunnels in the T tunnel model, the recovery and protection configuration, and also protection commands that Rajiv was talking about. And we also added examples of JSON encoded into the use cases. Next. So the remainder of this presentation is basically a repetition of the presentation in Prague. So I don't want to spend time on that. Can you go to the last slide? To the last, not to next, to the last slide.
The use cases or the next step?
No. The use cases were basically already. It was presented in Prague. So just next steps. I wanted to. Yes. So next steps. We wanted to add the definitions and use cases that were recently added. We didn't finish this work. Okay, and we want feedback from the working group. Basically, do you guys think that it's a useful document? And if so, we want to make it working group document. That's all.
Okay, as a reminder, this is an informational document to help understand our work on TE topology. I think it's very helpful. We see even inside the working group, there's confusion, as Igor mentioned. It's even worse when our customers don't understand what we're doing. How many think that this is a useful type of activity for the working group? That's a pretty good number. How many have read this document? It's about the same number. I'm surprised. I expected it to be about half. How many think that this document would be a good foundation for work in this area by the working group? It's also a good number. I think it shows reasonable support and similar numbers for all three questions. So we'll definitely take this one to the list. Thank you. Thanks, Igor, for giving some time back.
Pleasure.
Oui. Here I will introduce our consideration for applying PCE in native IP network. We have some we have introduced the topic several times, and here we just make some summary and a new proposal. We call it abbreviated. We call it the Central Control Dynamic Routing, the CCDR. Oh, sorry. Oh, I will introduce the scenario summary and our requirement and give our proposed solution. We also compare with the current technology and some of the further actions. Here is the scenario summary that we have introduced in last IETF meeting. There are 4 scenarios that we required the traffic engineer really in the native IP network. The first is QoS assurance for the hybrid cloud communication for end-to-end QoS assurance. The second is traffic engineering for our IDC main asymmetric links. The third is we want to increase our link utilization based on the tidal phenomena, because the different devices connected to different customers, their traffic has a tidal phenomena. The last is we want to eliminate the temporary network congestion. So this is the 4 scenarios that we are encountering in our zero network. Based on this scenario, we are seeking the solution that can meet our meet the following requirement or our expectation. The first is the solution can apply for native IP network. The second is we want to apply that it is identical deployment for the intra and inter domain. And the third is we want a solution to have no influence to the existing router forwarding behavior, because there are a lot of routers within our network. We cannot change them at the very short time. The fourth is easy interoperation for router from different vendors, because our network are comprised from by the router from the Cisco, Huawei, or Juniper and Nokia. The fifth is because we want to use the PC, we want the protocol or API interface friendly to the software engineer. And the sixth is we want to utilize the power of the central controller, such as the PC, and the flexibility and robustness of the distributed control protocol. The last requirement or expectation we want to the solution can cope with the different requirement for large amount of traffic and the prefix, because our network has about tens of byte traffic and tens of thousands of prefix in our network. Here is our proposed solution. First we want to deploy the PC or SDN controller in our native IP network. This controller is responsible for the complex algorithm to optimization the necessary traffic upon the zero network situation, because the controller has the whole view of the network. And we use the distributed protocol to populate the traffic via the different BGP sessions between the peers, and manipulate the path to the BGP next hop of this prefix via PCE to different the traffic forwarding paths. We have introduced it very detailed in the last meeting. So if anyone is interested, I can discuss the solution later. We have summary this solution, the benefit of this solution is because the PC controller has a powerful capability to solve complex traffic engineer scenario. And we have also finished the large network simulation. The below two graph is the simulation result we have introduced in the last meeting. And the kind of solution can deployment in same manner for the intra and inter-domain for native IP network. And later we can easy to expand to cover other kind of network. For example, for MPL traffic optimization. And this solution can exploit the advantage of central control and the distributed protocol. We have submitted 3 related drafts for this scenario and the solution. The first is the scenario and the simulation from the China Telecom, BPI, and China Mobile and Tencent Company. They are all have the large native IP network and want to do traffic engineering. The second is the framework for the solution by experts from the Huawei and Tencent and Juniper and ZTE. The third is the PCAP protocol extension proposal. So we also think what is our proposal need in the end. There are three decisions we want to get for our solution. First is we want to select the PCAP protocol to transfer the policy to router. There are also lots of discussion about this within the PCE working group, and I think we support this direction. And for kind of proposal, there are only 3 key parameters need to be transferred or need to be expanded for the PCAP protocol. Here is a list of the new PCAP project. So if this draft accepted by the TEAS group, we can discuss it detail in the within the PC working group. And for our scenario, we also compare with other technologies, but it seems none of them can meet the requirement of our expectation for the mentioned scenarios. For example, the first is the segment routing, because we think segmenting is not the same solution for the intra and inter-domain, and require the change of the fault behavior on the PE router, because there are many PE router in our network, and for interoperability, the SR requires the map server for coexisting with the non-SR router. The second is the RSVPTE. It is I think everyone here know it. This protocol has a single modem and state pressure on routers. The third is OpenFlow. I think it is cannot cope with the pressure from large amount of traffic, different requirement, and it emphasizes only the central control, not accepted by the network operator. The last is the network young. So some person have said we can realize our solution to avoid the network young, but we think network young have the following maybe some weak point. The first is the every yarn has a detailed, elaborate configuration style. This is not easily understood by our software engineer of the SDN controller. So they prefer simple abstract command. The second, we consider the efficiency, and so because the network yarn is in text style and the PCAP is in binary mode. And for utilizing the network yarn, we want to use it in the initial configuration. But for the dynamic adjustment, we want to use the PCI protocol to meet our requirement.
Just a few comments. So segment routing over with6 data plane doesn't require mapping server. It gives you everything you need really. The netconf command, netconf is heavyweighted, I agree with you. However, restconf or gRPC give you pretty efficient encoding and transport for ephemeral configuration. So there's no reason not to use.
Excuse me. Is this slide in any of the drafts, or is it just part of the presentation material?
Just a presentation.
Okay. So whether or not we agree with the slide or not, it's not in the documents. So
it's supposed to represent the document, right? So the netconf Yang, if you replace netconf with something more efficient, it works pretty well.
There's a lot that I disagree. There's a lot that I disagree with as an individual on this slide, and I'm just restraining myself because it's not in the document, so I'm not going to worry about it.
Last comment with regards to complexity. Anytime you deviate from SPT, you create potentially non-loop-free condition. So complexity, computation-wise, it's a very complicated solution.
There are some sentences mentioned in our draft to compare with the current technology.
Thank you.
Upon this consideration, and we have made several presentations, we want to the working group to accept the such scenario and the solution draft, and after that we can discuss in detail PCI extension protocol extension at the PCI working. Okay.
Hi, Adrian Farrell. Thank you for this. I want to just clarify something in my head, that taking an IP network, running an IGP, and putting static routes into that network is something we've done for a long time, but the interface has been typically CLI, and the management has been some human looking at what they want to do. And so the essence of your proposal is not really changing anything that's happening in the network. It's changing the way we interact with the network. So you're proposing a central controller and a protocol that's uniform for putting the static routes in, not any substantial change to the way the IP network works today. Is that correct?
Yeah. Traditionally the IP network is distributed, controlled by human, so we have no capability to provide the customer for the end-to-end service. So we need the PC or central controller within our network, and but we do not want to change our network dramatically. So we want to develop the northbound interface, not the east-west interface.
Other comments, questions? How many think that working on TE for IP networks is something that we should be doing in this working group, independent of the specific solution, but just the topic is something we should be considering? When we do TE in the IETF, it's our scope. So the question is to the working group, should we be looking at this? How many think that it's interesting? That's a few people. It's actually, quite honestly, more than I expected. It's not a great number. It's a few people. If we said that we were looking at this as experimental work versus standard work, so that we would provide a home to sort of foster the development of this and see where it goes, how many would be interested in it, and I'm explicitly asking for those who've raised their hands before not to raise their hands now. So are there any that would, by making this an experimental effort, would that be interesting to you to have in this working group? Maybe I'm not being clear.
If this is interested in industry and people willing to deploy it, we should definitely look into it. But be an experimental.
In here are really bad when you're sitting up here, so I'm sorry. Just speak a little louder or get a little closer.
If there's interest in industry and people willing to deploy it, as IETF, we should be looking into it. But it's normative work. I'm not sure. Experimental, yeah.
Okay. So you think it's good for us to be working on it. You're unsure about whether it should be standard, experimental, maybe makes it a little bit better.
Yeah.
Okay.
Again, if there's interest, we should give it a chance.
Okay. I think we would like to take this to the list in the form of a adoption poll headed towards the work being experimental. Now, that covers the first document. The last document in the list, there's 3 documents here. The last document would definitely belong in PCE. There's a middle document which is talking about sort of more of the architectural concepts. I'd like to get with the PCE working group chair to think about whether they want to do it sort of together, those first 2 documents together, or they prefer that second document show up in PCE. Given that we're likely to head this as experimental, I think it's less important. But I still think it's right to hear from the PCE working group chair what they think. Whether you want to come up now and say something or wait till offline, that's fine too.
John Hardwick.
Get really close.
Yeah, John Hardwick. Yeah, so this was discussed in PCE a couple of meetings ago, and I think I just want to I wanted this to come to TEAS because I wanted some sort of guidance on whether this was sort of a problem that we all want to be working on, and I think, you know, having a poll in TEAS to see if we want to adopt this as experimental will give me the information I need to see if we want to keep talking about it in PCE. But for now, I don't think we're ready to poll for any kind of adoption in PCE for the solutions. I would prefer to see progress here before we do that. Does that answer the question? Yeah.
Okay, that's completely reasonable. All right, so thank you. Sure. I think that the next 2 are for you, and you have the rest of the session.
Okay, great. So let's start with the use cases for software function-aware topology models. Basically, this is all about use cases that could benefit if the service functions are viewed as topological elements. And this document describes a bunch of such use cases. So, for example, Dhruv in his presentation also was talking about similar use case, at least along the same lines. And in his language, it was basically a virtual network, which is enriched with software function information, so that service functions could be discovered and moved around the network, and it would be possible, for example, to replace a failed service function with another one on a different destination. So, in our view, it's not VN. It's a very natural and relatively simple evolution of the topology model. Next slide. Right. So it was. This is not the first time we presented. It was presented in Prague, and since Prague, we have like a few changes. We have two new co-authors, Luis and Didier, joined as co-authors. Okay. We have a new section, which is a terminology section, defining what is network function, service function chain, transport function, and stuff like that. And we had like a lot of discussions. Next slide. So this is what service function aware network topology looks like graphically. On this picture, you can see that service functions are really elements of the T nodes, right? And if you think about them as elements similar to link termination points, tunnel termination points, that you also know, and if you also know how these service functions could be connected locally and at what costs, right? So having this information will provide you basically a very good graph to dual optimize service function chains, having two optimization criteria in mind, service function location and the T connectivity between them. Next slide. So for example, you can compute a service function chain which has traffic engineering constraints, like for example, a service function chain which has end-to-end delay or delay between various adjacent service functions in the chain. Next slide. So you also can think about things like service function chain recovery, like here's your original service function chain, and then let's say one of the functions, like service function 2, is failed for some reason. Right. Next slide. So you see, then you can actually recalculate service function chain and pick up another service function which performs the same functions, but reside on a different node and interconnect them with a different T tunnels. But at the end of the day, you will still have the optimization and constraints in place. Okay, next slide. Yes, and this is what, if the entire node, like entire source node goes down, you still can go start your service function chain from a different node and can come up with a service function which is still optimized correctly and have proper constraints. Next slide. Yeah, you can also do things like service function load balancing, setting up like parallel service function chains and distributing the services between them. Next slide. Right. So one thing is important, that this is not about layer 3 and up. Service functions or transport functions could be applicable in layer 0 and 1. For example, you can think about optical trails with 3R regenerators as a service function chain, and you can dynamically select the proper regenerators on the network and basically compute service function chains in such a way that you can minimize, for example, how many regenerators you need for a particular service function in order that the signal on receivers will be optically reachable. Next slide. So, and of course, you can model, for example, entire data centers as a single node and put all its computer storage resources as service function and create, again, service function chain which go across the network and between data senders and can still satisfy your delay constraints, for example. Next slide. Okay, so the next step, so we want to solicit more feedbacks from working group. We have some discussions, but those discussions were not on the list, so we would like to have some discussions on the list and identify more use cases if it's possible. And also, we want to relate this work to the network slicing because we believe that this could be a very good basis for network slicing. I mean, the software function-aware topologies. That's it.
This is Dhruv from Huawei. Clarification question: can this model be useful if I'm using VXLAN tunnel, and if that's my common case that I am using SFC and underlying I'm using VXLAN? Would my model be still useful? Because there are some things in this model which are which I find very interesting and are useful. So, is it only when underlay is T tunnel that's where this comes in, or can I reuse VXLAN?
Yeah. Well, this is we were talking about T tunnels, but basically we do not want to basically to narrow down to the traffic engineering tunnel. It could be any other tunnels that interconnect service functions. But the point is that if you have just reachability tunnels, then it's not really important where the service functions are on the topology, right? So that's why we see that it's more important when you have when you pin it to the T topology, and then you can do this dual optimization I was talking about.
No, actually, I feel like even though if you don't use T tunnel, since when we are computing the SF path itself, and if I have a choice between the same service function being available at multiple places, even though the reachability is the same, just looking at those properties, I can make good decisions on which service functions I should choose during the service function path.
Good point.
So, yeah,
I agree.
But it's very interesting work. Thank you.
Igor, why don't we go on?
Okay. So this is another presentation. Basically, me and Shufan, or Shufan and me, I should say, took the first step on the Young model that would take care of the software function-aware T topology. Next slide. As I mentioned in the previous slide, we want to view service functions as elements of the node, right? So those are guys, you see, these red guys, those are service functions. And we want to define them as opaque boxes, which could be identified by globally unique IDs. And we don't want to actually define service function per se. We want to reuse ETSI definitions so that a curious client, interested client, can use this service function IDs and get the details of the service functions that of the network, and, for example, understand to what extent they are mutually substitutable, right? But on the node, you have service functions which have also connection points, and for these connection points, they could be connected with each other in a local service function chains. They could be also connected to the what we call LTPs, right, link termination points, and thus to be connected to the service functions which reside on the neighboring nodes, and also could be connected to the TTPs, and thus could be connected to service functions residing on any node on the topology. Next slide. Right. So this is what I just described. So how we define service functions, how we want to reuse Tosca-Young data stores defined in ANSI, stuff like that. Next slide. Right. So one of the interesting and important concept of the T topology is connectivity metrics, right? And this connectivity metrics can describe the switching capabilities or limitations of a node, basically how the link termination points could be interconnected across a node and at what cost. So this model basically capitalizes or leverages this concept and defines three new connectivity metrics. The first one is service function to service function, which describes how the service function and which of them could be locally interconnected and at what costs. And then service function to LTP and service function to TTP, right? So basically, this is the connectivity metrics which describe which service function could be connected to which nodes LTP and nodes TTPs respectively. So at the end of the day, you have full picture which functions could be connected to each other on the node, which functions could be connected to neighbors, and which functions could be connected across the model. Next slide. Across the topology, I meant to say. Next slide. So one thing, what we are trying to also, we try to preserve the concept of virtual link, ETSI virtual link. And this is a concept we want to use when the connectivity between service functions on a node are negligible in terms of cost penalties compared to the end-to-end service function change. So, for example, if you do not want to deal with the costs connecting service functions to each other, you might use virtual links describing that these functions could be just connected, and that's it, right? So, and then those little service function change could be combined in a bigger service function. Next slide. So, this is what you can get using this model. Okay, the client can get, for example, or MDSC in terms of ACTN terminology can get from a domain a topology which has basically topological information, right? And also service functions which are sitting on the nodes. And this is what you can do and achieve, for example, ACTN goals like service function mobility that Daniela was talking about. Next. Next slide. Yeah, and this is like in the previous presentation, you could compute various service function chains using these models. Next slide.
We have your final slide.
Yeah, it's common. It's not immediate, right? So
it's okay.
Yeah,
do it anyway.
Yeah. So obviously it's just the beginning of hopefully it will be a long road. So we want to solicit feedbacks and relate again to the IETF network slicing work. Yeah, that's it.
Okay, thank you. Interesting early work. We definitely would like feedback from the working group. Please feel free to send it to the list.
Sure.
Send comments, please do. We are actually 30 seconds early. With that 30 seconds, I'm going to go back to an item that we forgot to mention or I forgot to mention in the opening slides, which is you may notice that we're only meeting once this meeting. We did not do the joint Yang session. Wanted to point that out to the working group and get feedback on whether or not they feel that it is missing or that the current format of having our individual working groups not synchronizing our model work across MPLS, CCAMP, and PCE. If you have thoughts on that, think it was a good thing, a bad thing, we'd love to hear from you individually or on the list. And with that, thank you very much, and we'll see you well, it looks like we're going to get a comment. Almost out at the door.
Yeah, Himanshu from Siena. before you adjourn the meeting, I wanted to make a note that we had requested last call on the associated co-routed FRR draft, and it's not in your update slides. So what is the deal?
The revision was posted yesterday, so we would like to give the working group some time to review it, and then we can discuss it on the list.
Okay, because yeah, we are keen on progressing that. It's a working group item.
Right,
And-
but yeah, you have to give the working group some time to
Okay.
review the doc.
Okay, thank you very much.